The launch of NASA's Voyager missions marked the beginning of an extraordinary journey into space, one that has continued to astonish us for decades. These missions demonstrated humanity's ability to explore not only Earth but also our entire solar system and beyond. Even after 46 years, these remarkable spacecraft are still providing scientists with new and stunning data about the universe, despite their technology being 3 million times less powerful than a modern smartphone and 1,000 times slower than our fastest 5G connections. Yet, these spacecraft remain at the forefront of space exploration. Recently, Voyager 1 made an astonishing discovery in interstellar space, one so unexpected that it challenges everything we thought we knew about the cosmos. This discovery has left scientists scratching their heads, wondering what exactly Voyager found and how it could change our understanding of the universe. Let's take a step back to understand the background of these incredible missions. On September 5, 1977, from Cape Canaveral, Florida, something extraordinary occurred. Voyager 1 was launched atop a Titan II rocket, starting its journey into the cosmos. Just 15 days later, on August 20, 1977, Voyager 2 followed suit. These twin spacecraft were originally designed to study the gas giants of our solar system like Jupiter and Saturn, and their moons. But they ended up traveling far beyond what anyone could have imagined, venturing into the depths of our solar system and even beyond, into interstellar space. Now, more than 12 billion miles from Earth, these spacecraft continue to astound scientists with their remarkable discoveries. Over the years, they've broken countless records, journeying farther from Earth than any human-made object ever has. Their voyage has taken them into regions of space no one had explored before, and they remain active, sending back data that continues to amaze researchers. The Voyager spacecraft have been working for much longer than anyone expected. They've gone far beyond their original mission objectives, and along the way, they've shattered expectations. Voyager 1 and 2's discoveries have sparked excitement in the scientific community, uncovering new and unexpected phenomena in space. Despite their age and the challenges of maintaining communication with these distant probes, NASA engineers have found clever ways to keep them operational. They've shut down non-essential systems to save power, allowing the spacecraft to continue their journey at least until 2030. For the scientists and engineers who have been involved in this mission since the beginning, the journey has been a mix of joy and bittersweet emotions. Just when they thought the Voyager missions were nearing their end, a stunning discovery came through from Voyager 1, one that has ignited a flurry of excitement in the scientific community. The data sent back by Voyager 1, along with its twin spacecraft, have become a treasure trove of information, sparking numerous revelations and rekindling our collective interest in space exploration. These spacecraft were meticulously built to gather clear data and capture stunning images while hurtling through space. Even before reaching the outer planets, the Voyagers were already sending back jaw-dropping images. When Voyager 1 sent back its first pictures of Jupiter, including swirling clouds and the Great Red Spot, it was a moment of exhilaration for scientists. But the real turning point came when Voyager 1 discovered something unexpected on Jupiter's moon Io. Far from being a dull, crater-filled moon like Earth's, Io was found to be the most geologically active body in our solar system. Voyager 1's instruments picked up strange signals from Io, and the images it took revealed enormous volcanic eruptions, some reaching higher than Mount Everest and covering an area almost as large as France. In addition to the volcanic activity on Io, the Voyager spacecraft uncovered a wealth of new discoveries about the outer planets and their moons. For example, Voyager 2 found that Europa, one of Jupiter's moons, has a thick, icy crust over 60 miles thick. This revelation led scientists to question whether moons like Europa could potentially harbor life, deep beneath their frozen surfaces. As the Voyagers moved further from the planets, they got a boost from the gravity of Jupiter, which gave them a slingshot effect, sending them toward Saturn and beyond. Voyager 1 flew past Saturn, coming close to its moon Titan, which has a thick orange atmosphere that intrigued scientists. This set the stage for even more discoveries, including Voyager 2's groundbreaking flyby of Uranus in 1986, where it discovered 10 new moons, and its encounter with Neptune in 1989, where it measured the planet's incredibly fast winds, some reaching speeds of 1,000 miles per hour. These discoveries were just the beginning. Voyager 2's close approach to Neptune revealed incredible details about the planet and its moon Triton, which turned out to be one of the coldest places in our solar system, with temperatures dropping to nearly -391 degrees Fahrenheit. Triton also has unique ice volcanoes that spew nitrogen gas and icy material into the thin atmosphere. These revelations made scientists realize just how unique and fascinating the planets and moons in our solar system truly are, even the most distant ones. Throughout their journey, the Voyager spacecraft were guided by the dedication and passion of individuals like the famous astronomer Carl Sagan. Sagan was part of the team that took the famous pale blue dot photograph, taken by Voyager 1 in 1990. Just before shutting off its camera systems, Voyager 1 captured one last image of Earth from billions of miles away, providing humanity with a humbling perspective of our planet. As Voyager 1 and Voyager 2 continue their long journey into the unknown, they continue to send back invaluable data. Their discoveries are not only challenging our understanding of space but also inspiring the next generation of scientists and explorers to push the boundaries of what we know. The Voyagers, though aging and far from Earth, remain a testament to human ingenuity and the relentless quest to explore the cosmos. As we venture into space, there's another critical element that makes everything possible. The Deep Space Network, DSN, often considered the space telephone line that allows us to stay in touch with our daring spacecraft as they journey into the unknown. So, what exactly is the Deep Space Network? While it's not as visible as a spacecraft, it's just as vital. The DSN is a massive network of radio antennas located in various places around the world, including California, Spain, and Australia. These giant dishes, some as large as 70 meters in diameter, act like space listening devices, helping us communicate with spacecraft that are light years away. Let's look at its role in the Voyager missions. The Voyager probes, with their array of cameras and sensors, served as our eyes and ears in space, sending back crucial data. To process this information and direct the spacecraft, we needed a strong communication system, and that's where the DSN came in. Imagine Voyager 1 heading out to the outer regions of our solar system, sending a weak signal back to Earth. This signal travels at an incredible speed through space, but by the time it reaches Earth, it's extremely faint. The DSN's massive radio dishes lock onto this faint signal, amplify it, and convert it into data that scientists can analyze. But the DSN doesn't just receive signals. It also sends commands. Space missions like Voyager are constantly evolving, and scientists and engineers may need to adjust their plans or instruct the spacecraft to perform specific tasks. These commands are transmitted via the DSN, essentially allowing two-way communication between Earth and the farthest human-made objects in space. One of the amazing things about the DSN is that it operates 24/7, constantly listening for these distant signals. It's not just a collection of antennas, it's a vital communication link that keeps the Voyager missions alive, even as the spacecraft travel farther beyond our solar system into the uncharted territories of interstellar space, the Oort cloud and the heliopause. Interstellar space is more accessible than the farthest reaches of our solar system. Picture the solar system as a balloon with a cloud of comet-like objects, held together by the sun's gravity. This cloud could stretch nearly halfway to the nearest star, and it will take the Voyager probes another 300 years to reach its outer edge. Interstellar space begins where the solar wind, a stream of charged particles and magnetic fields from the sun, ends. The solar wind creates a protective bubble around our solar system called the heliosphere. This bubble is gradually compressed by the pressure of interstellar matter, forming a boundary known as the termination shock. The point where the solar wind ends and interstellar space begins is called the heliopause, and it is estimated to be about 120 Australian dollars, astronomical units, from the Sun. Voyager 1 crossed this boundary about 20 years after scientists first measured it, detecting a sudden increase in plasma density. Voyager 2 reached this boundary in 2018 but found no major changes in the magnetic field, which was surprising because scientists had expected to see fluctuations tied to the Sun's 11-year cycle. Despite the Sun's solar wind being strongest when Voyager 2 arrived, the spacecraft's data challenged previous theories. As the Voyagers continue their journey, they are refining our understanding of how the heliosphere interacts with interstellar space. In simple terms, the Sun created a hot, ionized zone around our solar system that was later influenced by explosions from nearby stars. This region, known as the bubble, is much more turbulent than scientists originally thought, with chaotic magnetic fields and energetic interactions. These findings are helping scientists understand how our Sun's influence extends into the broader interstellar medium. Eventually, the Voyager spacecraft will leave this tumultuous region and enter the calm, unperturbed magnetic fields of interstellar space. But this will not be easy. Both spacecraft are still powered by a system that converts the heat from plutonium decay into electricity, but the power output is rapidly declining. In fact, the power output is now around just 4 watts per year, putting the missions into emergency mode. While it's remarkable to witness the Voyager's exploration of space, we're preparing for the inevitable moment when we must say goodbye to these legendary spacecraft as they journey farther into the unknown. The Voyager spacecraft captured 60 images during their historic mission, with the most famous one being known as the light blue dot picture. This iconic image was taken from a distance of 3.8 billion miles, making it the farthest photo ever captured of Earth. Even after 40 years, these spacecraft continue to send valuable data from the farthest reaches of space. Now let's talk about something a bit older. The Voyager probes still use an antiquated technology: the 8-track tape system. Yes, you read that right. 8-track tapes were all the rage in the 1970s, and these probes are still relying on them today. It's a testament to how clever the engineers behind this mission were, making sure that even the old tech could still do the job. You might be wondering why they chose 8-track tapes. Well, back in the early days of space exploration, digital storage wasn't as advanced as it is now. They needed something robust and reliable to store important data, and the 8-track tapes were the perfect solution. What's even more fascinating is that these tapes hold more than just music. They store critical scientific data about planets, moons, and the space between stars. Essentially, these tapes contain the answers to some of the universe's greatest mysteries. Now, consider the extreme conditions the Voyager probes face: extreme hot and cold temperatures, space radiation, and the vast emptiness of space. Yet, despite all this, these spacecraft continue to thrive, much like sending your grandparents on an expedition to Antarctica and having them not just survive but flourish. So, what made the Voyager mission so successful? One of the key reasons is a technique known as gravity assist or gravitational slingshot. Think of it like a space dance. Instead of relying solely on their engines, the Voyager probes used the gravity of massive planets to slingshot themselves forward, saving fuel and increasing their speed to explore even further. Let's break it down. Gravity assist works by using the gravity of a planet to boost the spacecraft's speed. Imagine Voyager 1 approaching Jupiter, the giant gas planet. The immense gravity of Jupiter pulls the spacecraft, giving it a speed boost like a space power-up. But there's a catch. If Voyager 1 hadn't approached Jupiter in just the right way, it could have ended up off course. Luckily, NASA's engineers got it perfect, and the celestial dance with the planets was a huge success. The precision required for this maneuver is astounding, and the engineers didn't just get it right once, they managed it multiple times. Voyager 1 used Jupiter's gravity to slingshot into interstellar space, and Voyager 2, not far behind, used assists from Jupiter and Saturn to reach Uranus and Neptune. These gravity assists played a massive role in the success of the Voyager missions. Without them, the probes would never have been able to complete their incredible journeys. Voyager 1 made it to interstellar space, and Voyager 2 wasn't far behind. The success of these missions relied on the extremely precise gravity assists they received. The concept of gravity assist is simple, but executing it is incredibly complex. Voyager 2's grand journey required impeccable precision. If they had missed any of the gravity boosts, the entire mission could have failed. But the scientists and engineers were determined to gather as much data as possible. Their work not only led to a better understanding of gravity assists, but also revealed even deeper secrets about the vast expanse of space. The Voyager missions, with their use of gravity assists, have greatly expanded our understanding of the universe and continue to inspire future space exploration.